What up, y'all? What up in this Izzy? Good to see y'all. This podcast 8.2. Hey,
Stopped.
it's fine. It's fine. We're good. I'm confident.
You talk like you're like
I'm 99%
in high school
that you're the
back when you were in high school.
Yeah, we're gonna go through 8.28 and then this check your understanding here. Hopefully, this is helpful for you, and we'll show that answer in a second.
Why are you touching all of this stuff?
Okay. Anybody still working? Is anyone still working? D, the last one? Perfect. I'm going to show it here in a second, Harry, and then we'll explain it. Is that cool? All right, hey, let's do this. We're going to show it, and then before we get into that next section, we will take just a quick breather here, okay? All right, check them real quick. I know Harry said part D was the one to kind of look at. Again, when we talk about bias, there's a lot of bias opportunities on D, right? One potential source of bias that could skew this data is the students may not tell the truth about their GPA. Like if I ask, hey, what is your GPA, and I didn't actually research it or I didn't have access to that, that could be something that would skew the actual interval itself, right? What would that skew it towards? Probably the higher side, right? We would expect it to be higher. So that would be something that might be biased. You could have said something different, okay? Maybe this includes students who take a ton of electives. I don't know, something along those lines. Or maybe where electives aren't impacted or influenced. Correct. Just thinking through, like, what are some things that could mess up that result to make this actually what we call bias, where it's not really a true representation of the population. Cool. All right, good stuff. Is there anything else you see up here that you're like, Coach, I need some help on that? As we're looking at it?
Do you want us to like say that this interval would be more narrow, or can we just say that it decreases?
Either one would work.
Okay.
I would take either. I know the one that Eric and I looked at on the homework, it said narrower, I think. I would just be sure to know, like, it could say either, right? Cool. And to help on 8.1?
Yes. I'm still like a little confused, but I'll just like go through it myself and figure it out.
Okay, well, let me know. Do you have any questions on this behind me while we're just talking?
I don't think so. I need to like process.
Makes sense. Yeah, just let me know. Anyone else have questions around?
Oh, this is the guy.
Okay. Hey, before we get to 8.2 day 1, okay? I apologize. I want to apologize in advance. The most important thing that I do as a teacher is teach bigger. It's bigger than AP statistics. We say it all the time in our basketball team. It's bigger than basketball, and I believe that. Your enrollment and your dedication in this class and what you do in this class is bigger than what you do on the AP exam. It's bigger than what you do as far as a grade-wise is concerned. It's bigger than that. And so for me, I don't teach in order to get great AP scores. That's just not, that's something that we're going to try to go to, but it's not the number one motivator for me. It is way bigger than that. And so our character developments that we do on block day, I realize that in the flow of our schedule, it gets really hectic in an AP class where sometimes I bypass that, right or wrong, to be able to go into the next thing and just kind of, because we got to roll. I want to really do a good job in this year in really taking time for that, even if that means, you know what, maybe we take a test later or whatever one day because of it. I think it's that important. I really do. And so today, one of the things that we talk about within my class for the last, I think it's been 4 or 5 years, is this idea of what is your purpose? And so I want to just quickly, conversation-wise, do you believe that God created you for a specific purpose? That when He formed you and He made you, do you believe, right, like whatever you think on either side, do you think that God has a purpose for you? And maybe give a reason why you believe that. Either way. Yes or no? You know I go deep on you today, did you?
No.
Just talking about, your life and the rest of your life. No, I'm joking. I'm sorry. That's bad. What do you think?
Yeah.
You do? Yvonne? Why do you think that?
Well, I like to think of myself as a pretty hopeful person.
Yeah.
So if there is no plan for my life, that sucks.
Yeah.
So, I don't know. I gotta think that there's somebody out there looking out for me and
Yeah.
has a plan for what I'm gonna do.
That's good. Other thoughts?
I think it's our job in life to find our purpose.
Mm.
Like we might have a set outline, but it's our job to discover what that is and explore.
That's really good. Love that. Any other thoughts? How many of you are not, you be honest and vulnerable enough to say, I'm not really sure. I'm not really sure on that. Yeah? That's good. I love that. So there's this, I'll give you this statistic. Do you know on average, this is a real statistic, that on average, millennials and then up, so kind of my age through to y'all's generation, the average amount of jobs that individuals will have within the United States is 14 or 15. We're not talking about I decide I'm going to Wesleyan, which I'm not. But if I decided that, we're talking about job changes, 14 or 15 in a lifetime. That's a lot. That's a lot. Now, part of that might be because the world's changing, jobs are changing, right? So maybe part of that has to do with that. Does anyone else have another idea of maybe why that could be the case? Yeah, there's a lot of that. Anything else?
If you believe something's right for you and then you try it out, you're like, this isn't it.
I'm out of here. Yeah, exactly. Any other thoughts? It's kind of shocking, isn't it? Do you think the majority of people like what they do?
No.
I would say not, right? I read a statistic, I don't want to say it, but I know it's above 60% of people are not satisfied with the current job they're in. And so why am I doing this? Why am I so passionate about this? For really the next 4 weeks, we're going to look into this just as a 5 to 7 minute block in between on a block day to really talk through what is your purpose? And we may at the end of these 4 weeks not be like, this is my purpose. Boom, gotcha. No, but to understand that, man, that God created you and He gave you specific passions, things that you're good at, and we'll talk through those specific things. Be able to just say, okay, what am I going to do? And maybe just have a better understanding of what your purpose in life is. But here's my whole thing is life is way too short to be in the 70%. I don't want to go through my whole life and then all of a sudden I get to retirement. I've got 15 years left to live if I'm fortunate enough to do that. And then all of a sudden, okay, I get 15 years of retirement and all I'm doing is just surviving in the moment that I'm in order to get to those 15 years. That's an awful way to live, I think. And so because of that, I've seen that. I've read some books on that and really came up with this concept that we've been using. And it's right behind Grace here. And it's this idea, and Emily, this idea of ikigai. It's what is your real purpose? We do not have this definition or this word in our English dictionary, but if you went to Japan and you said the word ikigai, literally that is one word that defines what is your true purpose, or what wakes you up in the morning. And that's kind of a weird thing. I would never go up to Grace in our culture and say, Grace, what is your purpose? That would be weird. She'd probably either hit me or walk away from me, right? As she probably should. But in Japan, that's a normal question. If you said, hey, what is your ikigai, that one word entails the whole idea of what is your purpose. And it's pretty cool. I want you to check this video out. We'll talk over it. While we're doing this, the first thing we're going to focus on that sheet is you're going to put your name on it. And then right at the top, the question is what do you love? What do you love? It's pretty wide open. So you whatever you feel in your heart of hearts, what do you truly love? And by the way, you do not have to fill this out. This is not an assignment. This is, I think, more for you than me. I'm not going to look at this. So while you're watching the video, while you're taking it in, think about what in life do you, it's going to be individual, do you specifically love? All right. So check this video out, and we'll talk through it. I would say a couple things. If you feel it, if you feel like there's only one thing, that's cool. Up to you there.
沖縄には生きがいという言葉があります。毎朝起きる原動力を与えてくれるものだと思います。
目覚まし本当に遠くに投げ捨てようかなと思う時もあるんだけど、我慢して自分のお尻に鞭を打って起きて走りに行きます。
踊りの流儀道場に通っている生徒たちの成長を見るため、
そうですね、私の生きがいは、いつも馬に会いに行くために、仕事をしに行きながら、責任を持って人とママとも接していっていますね。
お客さんにがね、喜んでもらいたいと思ってしんだけど、
いや、自分には兄弟もいないし、この孫たちがたくさんいたまには孫たちが寄ってくるさに、もう本当これが生きがいである。
世界チャンピオンになりたいんだって、俺はなるんだって、家族のために、チームのために、自分自身のために、ということが生きがいですね。
家族があったり、友達がいたりいて、みんなに助けられて、こいつのために助けたいとか、それを苦にも思わずできたり、仕事も目標があって、それに対しての勉強や努力は全然疲れない、苦にならない現状のことじゃないですかね。一日楽しむために起きています。
沖縄では、ハッピー、毎日が、幸せであれば、それで生きがい。
Any thoughts there? It's a Netscape commercial. Yeah. That really was. And you knew it. You knew it. Charles has watched this one before. No, that's good. Any thoughts there on what was there? I wasn't trying to diss him. Any thoughts there? So if I said what is your ikigai, what would you say? You don't have to answer that right now. We're going to look at that a little bit more in depth. Before I do that, one quick thing and then we'll get started. Do this. Actually, two quick things. Your sheets you could keep with you if you feel like you're pretty organized. If you're not organized and you're like, man, coach, I'm going to lose this. I would recommend you're just doing the top. What do I love? Just filling that in with your name on it. I'm not going to read them, but if you feel like, coach, I want you to hold on to them, I'm going to allow you just to kind of put them up here in the front with your, maybe face down. So maybe it's just between yourself each week. But that will allow me to kind of bring them back from week to week, okay? So if you feel like that's you can go ahead even now and bring them up and put them face down, okay? Before we finish, I want to share with you a quick story and then we'll be done. 4 years ago, I had a student who, big burly football player. I for some reason, God just connected me and him in a way that was only it was unique in that way. I taught him for a couple years, really enjoyed having him in class, and kind of a cut up, but he's just a great guy. And he was here at JC, and we had a conversation. We didn't have ikigai at the time, but we talked about life's purpose and what that God had for us and that sort of thing. And he admitted, he said, we talked about, hey, what do you love? And he said, Coach, I know, I love kids. And you got to know him, he just didn't look like that type. And I was like, man, that's awesome. Like, I love that you love kids. He goes, no, Coach, I would love to be an elementary school teacher. And I'm like, that's not the character trait, huge guy. I mean, 8 of me, right? And so, he's huge. I'm like, dude, that's awesome, though. How cool is that? And he said, kind of started to get emotional. And I said, what's going on? Is everything okay? And he said, well, you don't understand. When I went and told my family about this, my passion, what I would like to do with my life, what I love. They told me that I wouldn't make enough money and I wouldn't be prestigious enough if I went into that. And man, I hurt for him. I was like, man, that's awful. To the point where his family said, man, we won't support you financially in your education if you continue there. And I was like, man, that hurts, you know? But how many people are out there that, man, they choose things based off of things that maybe not that they love it, but because of like money or success or things that look glamorous when in the end it's really not what matters. So just a thought, some things. That story has really stuck with me, and it's something that I just want to share with you as we go in through our Ikigai Part 1. Cool? Cool. Any thoughts there before we get started today?
Did he go to school to be an elementary teacher?
No, did not. This day, he does not. He is not. So, kind of sad. I love him to death. And maybe he'll enjoy something else. I believe that maybe he chose something and it ended up working out for the better. Did you get some? But unfortunately, he did not. All right, let's do this. Fiona, you got something?
I just want to say my parents had the same conversation with me last year.
Really?
About what?
I'm not allowed to be a teacher.
Really? Gotcha. I'm sorry about that. And the reality is that I don't know what to say. Actually, I don't know what to say. Yeah, I'm sorry. All right, are you all ready? Are y'all ready to roll Hershey Kisses? Are you ready today? This is literally, I woke up and I was like in a great mood and I was like, I get to roll Hershey Kisses today. How many of you have ever done this before?
What do you mean?
Oh, you will see. You will see.
On the ground?
Like, no, on the desk, but you are going to roll them, okay? Like dice.
Oh, yeah.
Alright, like dice. So if you've never done this before,
What?
Wait,
I lied.
Hold up. You make fun of me? You give me a hard time? Alright, take your 5. Does everyone have 5?
Yeah.
I think Hannah has an extra one underneath her desk, and I think Ivana, did you get yours?
Yeah, I grabbed mine, so now I have 5.
Perfect. Alright, what you're going to do today is we're going to go focus into section 8.2. So if you don't have it, go ahead and get this today. And I'm going to call this Give Me a Kiss. That's a little weird, so we're going to go to the next slide. That's probably bad.
You put it on the podcast.
It is on the podcast. We don't mean like kiss. We mean like...
Kid.
Alright, you're going to take your 5.
Not all of us, right?
Stop.
Oh, no.
No.
We need to pray after that. Alright, we're going to take the 5, and you're going to roll them, okay? Roll them. Here's the thing, okay? You're going to do this. Don't eat them. Don't eat them yet. You can eat them in a second, okay? But when you roll them, you're going to roll them a total of 10 times, and you're going to count out of 50, because 10 times 5 is 50, the proportion that land on their bottom, okay? All right? Here's a question before we do this. Do we know the true proportion of the amount of times that it will land on the bottom? No. So we're going to create a confidence interval, big picture, of what the true proportion is for the times that, or proportion that it lands on their flat side. Okay? Ready? Out of 50. Ready? All of us, go.
I do it 50 times.
Oh, man.
No, you do.
I really feel dumb doing this. That's okay.
Me
It's
too.
for stat. It's for stat.
0.
10 times.
Just put it right at the top of your page. Right at the top of your page. Once you record it, do it again. I want you to do it twice. You have 2 numbers. 2 numbers.
Wait.
Just do it once. Just do it once first, and then I'll...
Wait, I thought we did it 10 times.
So when we do it, like for me, right? I got
So 100.
13 out of 50 for me. So my, remember are we talking proportions or means?
You mean like everything 2 times? Wait, I thought
Correct.
you rolled them twice, and I was like, I thought we were supposed to roll them 10 times.
No, yeah. So 10
2
times
sets of tits.
twice. Yeah, 2 sets
So
of
100 total.
50. Cool. So this would be 0.26.
Dude, I think it's trash.
So here we go.
I'm cheating when y'all roll.
Yes.
Oh man, I'm on a roll.
I just got all 5.
Ooh,
Me too. I got 5. Harry, you trying to go? Yeah.
You'll never see a Hershey Kiss the same.
Well, there's a meeting to
You're gonna start rolling it. You're gonna be like, hold up, you gotta roll.
I was like, yo, I'm gonna get 5. I got 5.
Emily, I know you're gonna do it.
Dude, this smells so good tonight.
Yeah, you can't eat them until we're done with the lessons.
Is this what gamble? What are we doing? Gamble with Eric? No, Eric's too good at this game.
Yeah, I'm failed.
I really
I'm
I just got
no
full.
way.
Dude, Eric's I would not gamble with Eric on this one. I've rolled a couple Hershey's Kisses in my
Does anyone want more Hershey Kisses? I don't know if anybody wants more.
to get more. I would love to get
There you go. That's weird. There's a Hershey Kiss. I gotta be careful with this lesson. It's gonna be weird. Anyone want one more? I need one more. We'll go over here.
Sorry, Ivana. Sorry.
Hey, Eric, we got a kiss.
Dude, can we get a 2?
Okay.
I know.
You're welcome.
I'm failing.
Okay.
I need to do this. I'm gambling my life away. Someone please help.
You're gambling your life away. That's.
What are you?
This time I'm getting 30. This time I'm getting 30. I'm getting a pass.
That just made my day, by the way.
I've never said
Well, I actually do. I actually do.
Really?
Well,
Yeah.
I keep getting 2.
I just keep getting like 2 and 1.
Yeah, I know. I got
How many of you have never rolled
five,
Hershey Kisses?
zero.
Any of y'all? Man, y'all gotta get with it. It's a new trend.
Oh, I
It's a new
got
trend.
Oh,
I got 4 on my
It's got all. Oh, well, that one was already there.
I've only done 5.
Okay. Is everyone good on those two?
No,
I'm almost.
I'm so
Oh, you are?
low numbers.
Oh, yeah. I saw some.
You're just so copying me.
Sheesh. You're going to roll, ain't you? And just like that. 1. You haven't got 1 5?
I'm bad. I'm not a baller like you, dude.
When you do them, just put them on the top here. I know a lot of you just do this. We're gonna make this one the same. Okay? Make this one the same. So I want you to put your 2 up here. There's a reason for it. Okay? There's a reason for that.
It's just because she had it.
You already got the 5. Dude, why can't you do 1?
I'm just gonna say I was literally so hesitant. She did it when she was
happened?
Okay.
Oh, wow.
All right. So here's what we're gonna do. Okay? Eyes up here, because I'm gonna let you kind of go here in a second. Okay? All right. Is everyone done rolling?
Nope. Yeah, let me do the math real quick.
Wait, I got 3 more.
Okay. Once you are done, you may have 1 Hershey Kiss. No, you can have as many as you want. I don't know why I said that. All right. Yeah. Fur.
Eric, come on, let's get through the lesson.
When you eat them,
I'm getting through.
you will have more clout.
Oh.
Dang, is that your eating guy?
Oh.
Ooh.
Wait,
You're cooking him and me at the same time. You just cooked him and me. How does that even work?
You said he was happy.
This is true. Yes.
Okay, cook me.
Yes, that's right.
It just reflects.
I'm just trying to answer a question because they cut stuff on.
We have too much fun. This isn't legal. All right. Hey, real quick. When we look at our 2, okay? Is it illegal to have fun? Is that what you're saying? Legal. Yeah. We can't have, we're having too much. I never said that. I never said that.
I mean, JC is taking our computers.
Okay. Next
Alright,
topic. Here we go.
Alright, let's continue.
All right, so as we look behind me, I'm totally off track now. You'll notice 0.26 and 0.42, those were my 2, okay? Real quick, just big picture. Don't put anything down here yet. I want to keep this the same so that we can check, okay? All right, so just keep them up here. Now, as we look at those 2, can anyone tell me, in terms of the confidence interval, what is the word, raise your hand, that describes what you found up here? Someone raise your hand and tell me. Ryan? Not margin of error. That's a good thought, though. Rita? It's our point estimate. Very good. And remember, it varies from one to the other because of our... What? Oh, let me ask this. Say that again here. Good. It depends on our sample, right? Good.
Good son, bro.
I like it. Someone also tell me, just raise your hand, tell me the actual notation for what both of these would be. Ivana?
Would you do like the 0.26, comma 0.42?
That's a good thought because we're not at a confidence interval yet. Remember, confidence interval is estimate plus or minus margin of error, right? What we found is this point estimate right there, okay, based on our sample. What do we, notation-wise, say it refers to on this? Go ahead, say it together.
Formula?
Or just the notation of those two.
Like, is it p hat? Wait, no. Is it p hat because this is a proportion, so it's p hat.
Yep, good. It's a proportion from a sample, so we call it p hat. Nice. Good. Does that make sense? Are y'all good on that? So it's a sample related to a proportion. We relate it to p hat. Okay. All right. Good so far.
Yeah.
All right. So here's the deal. Before I let you go, a couple of things, 2 things, and then I'm going to let you go ahead. This is going to heavily relate to chapter 7. You say, Coach, what was it? I forgot. Remember sampling distributions? You're going to see a lot of this as being the same thing, okay? A lot of it is being the same stuff, okay? Now, it's different in the sense it's a confidence interval compared to a sampling distribution, but it's going to be similar, okay? Now, on number 1, I want this to be the same. So I want you to hold on to these two because we're going to do something with that in just a bit once we get to the end. But before we get there, let's do this. Let's make the point estimate the same. The point estimate, we're going to just use my second one and make this 0.42 is equal to p hat, okay? So p hat is equal to 0.42, and remember, this is just our example, okay? Good stuff. Now, here's what I want you to do before we continue. Go to number 8 and put a line right below it. And put something there that just says stop or something that identifies that you're going to stop right there. I want you and your group or your partner to go as far as you possibly can based on what you know and try to see if you can actually solve for numbers 1 through 8, okay? I'm going to give you about an 8-minute head start and then we'll come together and kind of formalize it together, okay? 8 minutes? Should I give more?
No, I'm just saying, why is it a head start?
Oh, just so that you...
not going over it with us.
Yeah, so I want to see how far you can get, okay? Ready? And go. Let's do it.
Are you serious? Yes. That's okay. Yeah.
Oh, random sample. Yeah. Boom.
Bro, what you looking at?
Let's be the middle. What? Be the middle.
I guess like
15, 24.
yeah.
See? And you have to find the middle. Yes.
Oh, that's it.
Rita, tell
Be like that.
where you take the middle of these two values.
So that's a sample of the population. The population would be yeah. I don't know if it'd be in the bag or all.
What?
I know, me too. Yeah, my brain. I'm like, I don't talk to anyone on the anyway.
That's just not true. Like, that's very sad.
Or no, it's not.
Yeah.
Well, I mean, yeah, but I am also
Help yourself, y'all.
I don't know what those do.
Just don't.
No, don't be.
No, I got
Yes.
Really, yes. Except the sample was from how many? It was 5 we rolled, but really, I didn't want to give you this many. There were 50, right? One there. So it's 50 was like the sample. And then our size.
9, 7, 9.
True. There you are. Good, because that's the world we're living on.
Are we using our
This
own
is
framework?
8.2. Do 0.42 right now, just so that we can kind of be on the same one. That'd be good.
What's the 0.26?
Those were just my 2 up there. So yours could be different. When you have your 2, hopefully you had 2 different ones. Just put them at the top there because we'll use them at the very end. But because I want to keep it the same so people aren't confused, we just said we'll use 0.42 when we're done. And we got it. All right. Do you have questions on the 3?
Yeah.
Was it?
No, I was just saying.
You good?
Because each time you rolled was different, right? Oh, yes. Remember we talked about something being random. It's important because if I said, okay, I'm going to take 5 people to average the amount of time they spend on that. Can I generalize that to the population?
I was, I just don't know
No.
what I did.
When I use something that is random,
Oh, yeah, you're covered.
I'm able to now generalize to my whole population. So I'm using the 50 that are random, the rolls or whatever, to estimate to see what the true, right? Trying to estimate it and generalize it to every Hershey Kiss known to man. And again, since we're in the are we confused? Is anyone confused with parts of this?
No, we're listening.
I think I'm
Okay. Charles, are you okay? If you are, let me know. Would y'all mind putting number 2 up for me? Just, I think, was it population and all that jazz? You want to just throw that up there?
Oh, well, you gotta press the marker thing.
Was this random when we rolled it?
Yeah.
It was, right? Why is that important? Good, there's no bias, and so when we
Already said it.
right? We can generalize it to
Be a man.
The
population, right? Think about this, think about the opposite. What if I went and picked 5 people out that I want, and I said, okay, what is the average time that they spend?
Ew, my handwriting looks awful.
Yeah, it does. Not gonna lie to
No,
you.
because it wasn't random. But if I randomly selected 5 people, that is general, I can use that to generalize to my whole
The
population.
statistic estimates the parameter.
Remember with the confidence interval, what is the big picture?
So is the sample
Big
point
picture is I use a sample to estimate
For the parameters. And the
One of the,
Why would
is that
you
better?
Excuse me, Eric, yesterday when we wrote this
That's the
down,
formula.
Yeah, what's up, man?
he put a question mark for parameter.
You know what? It's okay.
We'll just see.
I mean, I don't know. I
I just
That's why we don't have P.
That's why he says. That's why it says that in the thing. It says that in the.
That equals square root of P times 1 minus P over N.
Oh, yeah.
In the sixth question, we had to use P.
Well, wait, you said it was okay.
So we're right?
I don't know.
Oh, so we're right. Wait, I'm sorry, what? Oh, Eric, I said favorite children.
But you understand
What? I'm sorry.
favorite children. If I were to see example.
Remember the square root
Oh,
of
me
P
too.
over N.
That's a little cocky. I know.
Let's just all get a 5. We don't have to argue.
Does that make sense?
Yeah, let's just say, yeah, you said we were wrong. I'm just, are we
I would say-
right? Were we right?
I'd say you're wrong.
Oh, did you not? Y'all got
Good.
that wrong. Is on God exactly what you said.
All right, we got a couple
I thought we were
more
family.
minutes.
Is this a team? Or you can argue?
No.
We are
We can stop arguing.
Oh, I don't know. I vote just forgot what Eric said.
Are we arguing right now?
Yeah. I think
We're having a debate.
Oh, never that.
They believe we're wrong.
Beefs all around.
Are we wrong?
I like beef. I like chicken though. To be honest.
I don't want
That's a
to.
party line right there.
All right, hey, let's do this. Let's go over this together. I noticed that as we went through, that there were you probably fell into one of two categories. One was like, oh man, I kind of get this, and then the second category was, oh my goodness, what's going on? Okay. Here's the thing. I just wanted you to try to see if you could approach it. You're going to see a lot of this is a repeat of what we did over chapter 7. Okay. All right. So hey, listen though. I'll tell you this. This is not going away. So what I'm about ready to go through is really today and in through Friday is extremely, extremely important, okay? All right? So really dial in. Really dial in here, okay? All right, so as we went through, Ryan, you did a great job. Hopefully you got this. Population, all Hershey kisses. Sample, 50 kisses in the sample. 0.42, which is our p-hat value. That should be our statistic. And our parameter is our... Really, it's a question mark because what is it? The true? Say that again, Grace. The true, except we're in what world? Not mean world, but... Grace? Yeah, proportions, exactly. So the true proportion, and someone raise your hand and give me context, the true proportion of what? Claudia, you got it?
Of all Hershey kisses, like tosses,
Good. And those that landed
like on their
upright, yeah, on flat or whatever. Okay? Good. All right. Did I say that this is important? Okay? What I'm about ready to go through, dial in. Here we go. Next one. Number 3. Was this sample a random sample? Harry.
Yeah, it is.
Yes, it is. Yep. Why is that important? Kind of talked about it earlier.
Because there's like no bias.
Well, it eliminates bias that's there. That's really true to make sure that it's representative there. Hannah, you got something?
yeah, it's so you can generalize it's the population. So like the 50 Hershey kisses, can like tosses can generalize to like all Hershey kisses.
That was rocking. Great job. Yeah, so we want to generalize this to our population, all right? I want you to put something off to the side of this because this is important. I want you to put condition 1. You say, what does condition 1 mean? I'm going to go through it, back through it, but you just need to know that's my first condition, okay? First condition. Good stuff. You're welcome. Number 4, again, all of this comes back to sampling distribution. That's why I said 7's not going away. So you got to really know all of the stuff in terms of how it's applied here, okay? We got something, Fiona? What would it be?
Sigma to p hat.
Yep.
Equal to the square root of p times p minus 1 over n.
And I think I told you wrong. 1 minus p all over n. Rockin'. And so when we talk about that, that would be our standard deviation for the sampling distribution of p hat. Is anyone confused on this so far? Nothing crazy, right? Okay, here we go. Next part. What condition must be met to use this formula, Jared?
Is it the 10% rule?
Money. Good. And what does my 10% say?
That's the one where it's little n.
Yep.
Is less than or equal to 1/10 big N.
Good. Good. What is little n for what we used here? 50. is less than or equal to 1/10. What is big N?
Like infinity, all Hershey kisses.
All Hershey kisses, tosses that landed flat today. No, I'm joking. You don't have to say that. You could just say all Hershey kisses, tosses. It's just kind of fun. All right. Good stuff. Is that true?
Yes.
Yes, it is. And therefore, we can use the standard deviation formula. Okay? I want you right here, I want you to put this on the side. This is number 5. I want you to put condition 2. Condition number 2. Okay? All right. Good. Harry, you got a question or you got
For number 4, like
Yeah, shoot.
why is it like not standard deviation over like a radical n?
Great question. Could someone answer why is it not sigma over square root of n? Oh my word, this is crazy. I'm gonna go Eric, come on.
That's for the mean world.
That's the mean world, right? Good. Because we don't know what the mean world is, right? We're talking proportion. That's why we'd be that way. Hannah?
Is 8.2 all just proportions, and then 8.1 is just all means?
Great question. 8.1 was introduction to confidence intervals. We talked about how to interpret. Really, that's all we talked about. Interpret. We talked about what is a point estimate. We don't know what a margin of error is other than like that number, right? That's left and right there. That's really all we talked about. 8.2 is proportion world. 8.3 is what? Mean world. Cool? Mean world. Excellent. All right, let's go to section 6 here. Number 6. What condition... Oh, we already did this one, didn't we?
Yeah.
All right, we're Gucci. Number 6. We don't know the value of P, do we?
No.
Can someone tell me why that's the case, Ryan?
Oh, no. I just.
Claudia?
Because P is the true proportion, and we don't have like the whole population of all Hershey Kiss tosses, so we only know that.
Exactly. We how do y'all say it on text? DK? Don't know.
IDK.
Oh, that's what that meant? I thought it was I don't care.
No, that's
IDC.
Oh!
Here starts with a C. Here starts with a C.
Charles, you get it? I don't know.
Do you know IDR?
Care of the K?
I don't realize what's going on.
I don't remember.
Oh.
No, because I don't hear is IDC.
DK. I do. Hey, when you teach someday, y'all can do it whatever y'all want. DK. DK. All right. Donkey Kong. Sorry. All right. So we're gonna use p hat instead. Okay. We're gonna use p hat instead. Okay. This is too fun. All right. So when we use this, this is now because we're estimating p hat to my population.
Right.
We're gonna use p hat instead of p. Cool. So sigma of p hat equals the square root of p hat times 1 minus p hat all over n. Cool.
Yeah.
We still have to use the 10%, but that's why we're not using p, we're using p hat. Ryan, you got something?
Can I just answer?
On number 7? Is that where we're at?
Number 6, we're supposed to calculate it. Calculate the standard
Oh yeah, what was it? Come on.
It was
0.0698. Great job. Good. And again, you would want to make sure you showed it plugged in and done that. You did that, okay? Very good. Good enthusiasm, Grace. Good stuff. Things that y'all don't see that I see is amazing. It's amazing. Okay?
She do.
Yeah, she just between me and her, right? Number 7. Would it be appropriate to use a normal distribution for the model to estimate the sampling distribution of p hat?
Yes.
All right, now when you say yes, you got to justify here. Okay, stay with me. I don't want to lose you. Why, Ivana? Do you know?
Yeah, you do the law of large numbers. And so when you multiply,
Quiet, please. Hey, right now, stay with me.
you do n times p hat has to be greater than or equal to 10, and then you do n times 1 minus p hat has to be greater than or equal to 10, and so 50 times 0.42 is like 21, and that's greater than 10. And
Yes.
then the other one is 50 times 0.58, and that's 29, which is greater than or equal to 10.
That's awesome. Great job. Yeah. because of the law of large counts, put that down, because this is different, right? Someone might say CLT. You say that, I'll hunt you in your sleep. CLT is mean world. Got me? All right, very good. Law of large counts. Law of large counts. Based off of this, what does this show me, Emily? Do you know?
Oh, doesn't it just show you that it's like normal?
Great job. This is approximately normal, right? We can use a normal distribution, right? And that's important for where we're going. So that would be number 3. This would be condition 3. Put this down, okay? Condition number 3 is related to this 7 that's here, okay? Good. Emily was right. It approximates something as normal. As normal. Great job. Okay? All right. Good stuff. Hey, we got about 20 minutes left. This is where we kind of dial in, kind of bring everything together. So I know kind of getting towards the end of class, y'all paid attention great today. But these 20 minutes are important, okay? Number 8, here we go. In a normal distribution, 95% of the data lies within blank. What would it be? I'm looking for someone different. Someone who has an answer today.
Lawrence has it.
Torrance, what would it be? Nice job, yeah. 2 standard deviations to the left and right of my mean. Okay? All right? This, here we go, stay here. This is called a critical value. Okay? This is new stuff. That's why we're going through it together. This is called a critical value. When we talk about a critical value, think of it, we remember 2 as a definition. 2 is a specific definition. It could be positive 2 or negative 2. Can anyone give me what the term we use to describe that 2 that's there? So the distance, right? Like the margin of error could be like to the left and right. But I'm looking for something different. I'll give you 6 tickets if you can raise your hand and tell me. Eric, do you know?
Like 95% of all data will lie within 2 standard deviations to the left or right of the mean.
That's true. I'm looking for a definition that describes the 2 up there, though. 2 is something. It could be positive 2 or negative 2. That's your hand. Claudia?
Is it z-score?
That's correct.
Okay.
Yeah, it's a z-score, right? When we talk about 2 or negative 2 could be a positive z-score or a negative z-score, right? Does that make sense? Well, when we talk about confidence intervals, okay, a critical value, you need to make sure you really get this part down. The critical value we call Z star. Z star.
I don't like that.
Z star. And it's literally like an asterisk on top of it, okay? We call that our critical value. Okay? Now, when we look at this, we got to make sure we kind of identify what percentage of the data lies within blank of the mean if we're talking about 80%. The problem, though, with 80% is what? It's not like we can't find it because it's not in our rule, right? So we're actually going to have to solve this. So when we do this, just take a look at this part here. The middle 80%, I'm just going to make this up, is from here to here, right? So this is the middle 80% of the data. How can I figure out the amount of standard deviations to the left and right of the mean it is from 80%? How would I even solve for that? Does anyone know, Emily? Great job. Yeah. So, and remember, when we do that, right? I like that. Emily, you said almost everything right, okay? The only thing that, and by the way, could I do this on table A?
Yeah.
I could, right? I could find this on table A. But when I do inverse norm, right? What do I put in as my area?
I don't know.
Oh, you
Because-
have to do like less and then.
Wait.
Whatever that thing
Do
is,
you have
you
to
know?
do like 0.8 minus? You have to do like
Yeah.
0.7 or something?
It's like.
Not quite. Not quite.
Well, it's
Do you remember like
two.
when it was like find like 99?
Okay, so question. Inverse norm only finds the area that's to the left of the value, right?
Yeah.
So if I'm finding the value that's right here, that's right of my mean, what would I need to really put in for my area, Fiona? 0.2? It's a good
Wait.
thought. Actually, I could do that to find this one, right?
You would put point.
Cool. So I could put point. Hold up, it wouldn't be 0.2. It's point 1 because you got to think of both tails, right? Good. So it'd be 0.1 that you could put in for that, right? Or you could go to your table and find 0.10 and find what that would be, and that would get you what we call our critical value.
But how
Okay.
would you do it in inverse?
Inverse norm, let's pull it up. Let's do this. So it's going to come up here.
Wait, why would it be point one?
Why would it be? 0.1 is the area that's to the left of that value. Think of middle 80%. That means on each tail hand you've got 10%, right? So if I'm finding the 0.1, right, that's just at that tail, I'm trying to find what is the z-score from 0.1, right? Also, you could have done 0.9, right, to get to the right side. But as long as you find one, you'll be able to find the other as well. Cool? So when I go here, let's go to inverse norm. So we'll go second vars. Go ahead to inverse norm on the bottom right here, number 3. The area would be what? 0.1. What does the middle mean? 0.42 because we're using our estimate. And our standard deviation was 0.069, right? 68? I'm sorry. 698. Okay, my fault. Is that cool?
Yeah.
And there you are. So we would have our value on the left side. Hold up, inverse norm.
I don't understand.
I just messed up on that. I messed up on that.
But even if you did 0.8, that wouldn't be.
You have to do 0.1 times
So do you
2.
do
Do you do
the
0.8
and then subtract that?
Yeah. So what I just found, and I don't know what I was thinking. I was hopping ahead of myself. This is the area to the left of
Yeah, and they have to do it again to the right.
to the left side. Okay.
Right.
Remember, we're finding the z-score, technically, right? So what I would do is this is define the area, right? Inverse norm is define my area. If I'm finding what my actual z-score is, we would just use our regular value of our estimate, right? And then go from there. Does that make sense?
So you don't do inverse norm.
Because like at the top
Do you
it
do?
says.
Because like it
I'm
says
I'm
do.
confusing the heck out of
Do you
myself.
do normal CDF?
Wait, why wouldn't you just use 0.8 in inverse?
Because
Yeah,
that's
yeah,
not.
why can't you use normal CDF?
Yeah, why don't
Wait,
you do?
Emily.
I don't know why I'm confusing myself. All of a sudden,
Inverse norm.
Scott, set the roadblock.
Because wouldn't you do like?
She just read the board.
So think about it this way, right?
Oh, I didn't even get that.
I'm gonna need some help here. For some reason, and this happens sometimes, I'm good with it. What we're doing is we just found the area. Inverse norm, that's what it does, right? We're finding the area of something, or, hold up, no, I'm right.
But you put the area
I
in.
thought
How does
0.8
it
was the
give an
area.
Yeah, but that's.
Did I put that in wrong?
Yeah, you just did the point one.
Inverse norm is actually, I'm sorry, inverse norm is we have the area. What we're doing is we're plugging it in to find the value, right? It's the opposite of normal CDF. Normal CDF is finding the area. Inverse norm is to actually find the value. So we're actually right with this. I think I just plugged this in wrong. What we should be putting in is 0.1, right? 0.1 is the area that's to the left of.
And to find the area to the right also.
Yeah.
So couldn't you
So
just do
times it by
0.8
2.
and then find what that value is, and then find the 0.11 and subtract that,
Okay, but
so that you just find the middle 80.
Yeah. Because.
Say that one more time.
So you do the 0.8 so that you get everything
Or
to
you can do
the left of the
0.9.
0.8.
Or you
0.9 and
Point
subtract
nine, yeah.
0.1.
And then you subtract the 0.1 so that
Yeah.
you get the middle 80.
Yeah.
and add them together.
Here's what we just found, okay? I'm hearing you out. I'm trying to process this too. 0.33 refers to this right here, okay?
Yeah.
This middle value is 0.42. Would you agree with that?
Can't you just
Okay.
so we could just do point 0.9 and then subtract the 0.1 part.
Yeah, I can do that.
Yeah, that's a good thought. I would say in referring to that, right? We're trying to find the z-score either to the left or to the right, okay? All right, first of all, is everyone on board with, I want to make sure you're good. What we just found was at this spot, the value is 0.33.
Right?
The middle or the estimate was 0.42. We want to find the z-score between 0.42 and 0.33. If you're good, say uh-huh. Okay? To do this, let's just use z-score formula. So we do that by doing 0.42 minus 0.33 divided by, what was my standard deviation?
0.0698.
Good. Someone tell me what that would be, just on a calculator real quick.
Okay.
1.2.
Yeah.
Oh yeah, that's right.
1.289? Perfect. 289, it literally it's 0.282, but if you did that, that's fine. Okay? I'll tell you what, let's do this. I like table A better than the calculator on this. Could we do that real quick? I just want to show you this just so that we can. Table A, AP Statistics. Okay. Who's confused right now? As confused as I am?
I'm just confused
Yeah, I hear
why
it.
they told us to do inverse one.
That's monkey. That was more me. That was not. I should have done better on that.
It's okay,
I dropped the ball.
Michael
Michael Jordan, he misses them. It's good. You know, it's all good.
I blame Emily.
Okay. So when you come down, as you go to table A, okay? Let me see. Where are you? Where are you? Down here. Down yonder. Here we are. Okay. So right here. Do y'all see this? Okay. Remember when we find, we usually have a z-score to find the area. No? You good on that? Remember what was our area? It was 0.1. Cool, right? I like this table A rather than the other values because if I go to 0.10, 0.10 would be, where would it be? I'm trying to find it. Over here. So as I look at it, how many standard deviations is it? So this is the area, correct? That would be 0.1 or negative 1.28, right? Does that make sense? It's easier using table A and going backwards. The area is 0.10, right? Therefore, my z-score is negative 1.28 and positive 1.28.
I don't.
Let me do this.
Yeah, you KO'd me on that one.
Yeah, okay, I just
Did I get
don't
you?
understand. When we did the z-score thing, why did we do 0.42 minus 0.33?
So
Because,
what you're
like-
saying is you're only trying to find one side. Like you're not.
Because the other side would be the same, right?
Like,
Yeah.
isn't it value minus mean? So why do we do mean minus value?
I guess because when we did the thing about 2, and he was saying the hint about 2 is that it could be positive or negative.
Here's the thing.
And how would we have gotten?
Let me backtrack because right now, I think I confused everybody. Okay. And my apology. There
It's
should have
okay.
been better. So when we're doing this, okay, all I want you to do is just go back with me. Table A is what I would default to. Okay. Some of these you'll actually memorize. You don't have to memorize all of them, but especially 95%, which is the most common, I would just say, hey, just know that. As we look at 80%, what I'm saying is that the area here is 0.10, right? Because the area is 0.10, we found that the z-score that's to the left, and by the way, it's the same to the right, is 1.282, both negative and positive. How did I find that? By going to table A, right? Go ahead, Fiona.
Yeah, you just use the area to find your z-score. Or, well, kind of. And then you went to table A, and you used your area to find your
Correct. Money. That makes sense? I think that's easier. Let me show you another one because that might help. But that's what I would get here, okay? That's what I would get here. As we look at 90%, okay? 90%, if I looked at this one, all right, so here we go, middle 90%. What would be at the tail here? 0.05. So my question is what is the z-score here when we have 0.05 as our area?
Plus or minus 1.6.
How'd you get that?
I did it while you were doing it.
Bingo. That's fair. So let's just look at it real quick so you can see it. 0.05 is what I'm looking for, ish, right? So I would say here. So this one would be negative 1.64 as my z-score.
Okay.
Good.
So did you have to choose one of
I
the
get
numbers?
that.
Okay.
Can you go back to the graph?
Yeah, absolutely.
I don't get you did 0.10.
Yeah.
I understand that we did that. How is the z-score? I thought it was 1.28 for the top one.
Sure.
How is that this part?
Yeah.
when it's not including the 0.1. I don't think I'm understanding that
So
part.
what do those numbers mean, right?
Yeah, I just don't understand
That's
how
the
that is that from 0.1, that like line to that middle part.
No.
I don't know if that's making sense.
this is z-score, right? The area here is 0.8. When we have the area that's 0.8, the values on the outside produce a z-score that's plus or minus 1.282 away from my mean, right? Right? That's the amount of standard deviations away from my mean. When I look down here, we have a standard deviation. The amount of standard deviations away from my mean for 0.90 is negative 1.64 and positive 1.64, right? So what is our z star in a 90% confidence interval? It's 1.64. Cool? Kind of do another one. Do more. Yeah, Hannah?
On the calendar, it says that this quiz is over 8.2a. It's gonna be on the quiz.
No, just 8.1.
Yeah.
That's all, because I already made it. It's 8.1 on
Coach Day, I understand her question. So
Yeah.
she's saying if we have our little thing, you know, and
Yeah.
we're finding the middle part,
I'm just drawing it with you.
and you have like the 80 in the
Y'all,
middle,
hey, quiet, please.
and you have like the 80 in the middle, like
Yeah.
how that one is. She's saying if you found the 0.1 on the other side, how does that make it the middle part from like
Yeah.
the true to the end of it? Like how does that?
I'm hearing you. So I'm saying 80%. What's left over on either side? 10%, right? Because we're finding, and I'm going to get to your question, but I want to make sure some other people may have that different question. Each side is 10%, right? But remember when we go to our table A only finds anything that's to the left of a value shaded, right? So when I go there and I'm looking for the z-score of something, it only can tell me to the left of that specific value, right? So what we're saying is when we go to table A, I'm looking for an area of 0.10 here, right? So I'm asking the question, what is my z-score when my area is 0.1? My z-score in that example was 1.282, right? 1.282 here. So we're saying that at this specific value, we are 1.282 standard deviations away from my mean. Did I address that question? Did I?
I'm gonna try to explain it.
It's slowly.
Cool. It didn't help that I
just don't.
threw you for a loop. Did not help. All right. What do y'all think so far? Stay with me here because I think we got a little bit left, right? We got like 4 minutes left. Cool. All right. Let's do this. Let's do this one. Let's do 95 and then 99. Okay.
So that means it's showing.
All right, do this for me. Come, someone talk me through 95%, just real quick. Just talk me through it, okay? Let's do this. Let's go, Claudia, just talk me through it, okay? What would I do with that 95?
So with the 95, oh, do you want me, okay, yeah, you draw that, you label, like, you're trying to find 95%, so you
Cool.
label that that's 95%. Then you're trying to find 0.025
Nice.
to the left and the right, and then you look on your table A for the thing closest to 0.025.
Good.
And I don't know what that is.
It's right here, I think, which is negative 1.96, right?
Okay, and so that's the standard deviations away from the mean.
Good, which is also what we call my critical value, z star.
So it's close
Okay.
to 2. Is that why we say it's 2?
It's close to 2. Usually we use negative 2 or positive 2. I would just go ahead and use this one because it can throw it off just a little bit. Okay? Does that make sense?
Should we like label the numbers as like plus or minus because it's to the left or right?
You can. You'll see because of the confidence interval, it'll add and subtract anyway based off of our formula. So you don't have to, but you can. That's actually pretty good. Okay? It's good there. All right? So question, what would be the area I would find for this 99%?
0.005.
Is it 0.005, right? Which is the area on the tails. And then when I do that on 0.005, right? That would be 2.576, I think, is what our critical z-star value would be. Okay? All right, good stuff. Questions on any of that? I apologize. I don't know why sometimes I hit a brick wall there. Hey, go to this next part, number 8. We're gonna wrap this up tomorrow. Number 9. My fault. 9. So here's the thing: margin of error equals my critical value times my standard error. You say, Coach, what in the world are you talking about? Okay, let me show you. It actually would be this. It would be Z star multiplied, okay, multiplied by my standard deviation formula. P hat times 1 minus P hat all over N. Okay? Well, we know, what is our Z star of this?
For what?
It was close to 2. We were 1.976 to be exact, right? So we would say that Z star would be 1.976 times, what was my standard error, or my standard deviation? 0.0698.
You gave us 1.96.
Yeah.
Did I say that? 1.96. You're right. Should be 1.960 multiplied by 0.0698 would be 0.137. That is my margin of error.
Okay, that's not too bad.
Okay.
All right. So think about this for me for a second. What was my estimate? 0.42 plus or minus. What was my margin of error? 0.137. Okay? All right? So if this is my estimate, plus or minus my margin of error, what is my confidence interval? And this is why, Eric, the plus or minus comes into play here. Okay? So this is my estimate, plus or minus my margin of error. What would be my confidence interval? Good, Ryan. And? 0.557. Great. Okay. Good.
And that's like 95% confidence.
95% confidence. Excellent.
Because the Z score from 95%.
That's the Z star. That's where it's built in. Right? As we decrease that, right, that becomes more narrow, right? Becomes more narrow. Hey, do this on Friday. We're going to hit on this again. It's going to be built into Friday. So if there's a couple pieces that you're confused on, we'll hit it again, okay? My apology on that. Good work.
I understand.